Let's read through the problem and highlight important information. So in certain deep parts of oceans, the pressure of seawater, P, so here, when I saw that P, I realized they're defining what a letter or variable represents, so I want to write that down, in pounds per square foot, so that's the measurement that we're measuring P in, at a depth of d feet below the surface, is given by the following equation. P equals 14 plus 7/10 d. Use this equation to complete the statements below. Round your answers to the nearest tenth as needed. So let's write down our formula and what the letters represent. So we have P equals 14 plus 7/10 d, where P equals the pressure of the water, and that's measured in pounds per square foot. So I'm going to write that in pounds and square feet. So that's just a short version of writing that unit. And little d represents the depth below the surface. Of the water. So let's just take a second to think about this formula. So we would take the depth below the surface of the water, measured in feet. Okay. We'd multiply that by 7/10 and then add 14, and that gives us the pressure of the water in pounds per square foot. So now let's use this information to answer the questions. So here it says the pressure of the seawater is 95 pounds per square foot at a depth of blank feet below the surface of the water. So starting with our formula, pressure equals 14 plus 7/10 d. They're going to give us either the depth or the pressure. It looks like they gave us the pressure of the seawater is 95 pounds, so they're giving us the pressure is 95, and then they're asking at a depth of blank feet, so that means our goal is to find D. Okay, so they gave us one of the letters, we checked that it represented P, and they were asking for the depth, and D represents depth, so we're going to find D when the pressure is 95. So that means we're going to replace P with 95. 95 equals 14 plus 7/10 d. Now again, here we're solving an equation, so let's think about what this process represents. We would take D, we would multiply by 7/10, and then add 14. And this equation says if you take D, multiply it by 7/10, and add 14, you will get 95. So we want to reverse this process, and we will start by, instead of adding 14, we're going to subtract 14 from both sides. On this side, I see it right there. Here I'm going to line it up with 9/5, or 95, sorry. This would give us 81 equals 7/10 d. Now, here we multiplied by 7/10, so to reverse multiplying by 7/10, you multiply by the reciprocal 10/7. Okay? So notice 7/10 times 10/7 gives you 1. So multiply both sides by 10/7. And here notice the 10s cancel, the 7s cancel, we're just left with D. And then on this side, since it asked for the nearest tenth, we know we can write it as a decimal, so I'm going to do this on the calculator. So thinking about this, you'd multiply the numerators, 10 times 81. That gives us 810. And then we divide by the product of the denominators. 7 times 1 is 7, so we're just going to divide this by 7. And here's our result. We want to the nearest tenth, so that's going to be 115.7. So, putting in this phrase, the pressure of seawater is 95 pounds per square foot at a depth of 115.7 feet below the surface of the water. Let's look at the next one. Here they say the pressure of the seawater is blank pounds per square foot, so that's what we're looking for, the pressure, P, at a depth of 65 feet below the surface of the water. So we'll start with our equation. P equals 14 plus 7/10 d. And we know we're solving for P, and we are given a D value of 65. Okay, so we know depth of 65 feet. If you forgot, you can look up here. D represents depth below the surface. So we're given D, and we want to find P. So we're going to go to this equation, and we're going to replace replace D with 65. So P equals 14 plus 7/10, and I'm going to put 65 in parentheses because we're multiplying. And now notice P is isolated, it's by itself, unlike here where D was not isolated. So we can just compute this value, and I'm going to do that on the calculator. So we want 14 plus 7 divided by 10 times 65. And we get 59.5. So let's put that in our answer box and just read the phrase to make sure it makes sense. So the pressure of seawater is 59.5 pounds per square foot at a depth of 65 feet below the surface of the water.